Good morning. Can you hear me?
Yes, sir.
Okay. The screen is visible?
Yes, sir.
Okay. Okay. We will start now. Last class, we just started with a quick introduction for evapotranspiration. Just to repeat, this evapotranspiration is a combined term for evaporation which happens from topsoil, as well the water is drawn by plant or crop for its transpiration needs. So evaporation from soil, transpiration by the plant, combinedly it is known as evapotranspiration. And many a times this term evapotranspiration stands for consumptive use. That is the water which is used by the plant or vegetation. Why there are two names, evapotranspiration and consumptive use? In what way they rather differ in their expression? So in that context, we have to understand two other terms. One is known as AET, which stands for actual evapotranspiration. The other is PET, potential evapotranspiration. Sometimes PET is also known as maximum evapotranspiration. As we all understand, the water which is available in the soil in a phase system can be classified as hygroscopic water, capillary water, and gravity water or superfluous water. What do we mean by that? The hygroscopic water, which is below the wilting point, the water which cannot be drawn by the plants for its needs, rests there because of the affinity between water and soil molecules. That is hygroscopic water. The water which is available in the soil between the range wilting point and field capacity of the concerned soil is capillary water, which is available for plant needs. Anything over and above this field capacity, which is present in soil, that is water which is present in soil, at a slow pace will flow under the action of gravity, just like how the flow happens over the surface of the earth. That is, it will only stay temporarily in the soil matrix. Little later, it will flow depending on the gradient present in that particular direction, it would flow. That means to say that that flowing water is also not part of the soil moisture, because of which even that is not available for plant need. What is available for plant need is between the range, field capacity and wilting point, known as capillary water, which can be drawn by plant roots, which can be sucked by these plant roots for their metabolic activities. So that is what we are aware in respect of water present as a three-phase system in soil. Suppose if the water content in the soil is at field capacity, then complete requirement of the plant can be met. So in which case the evapotranspiration from the plant will be maximum, and hence it is known as potential evapotranspiration. When complete requirement of the plant, water requirement or moisture requirement of the plant is met, that is maximum it can happen, and that evapotranspiration is known as potential evapotranspiration. Whereas for any reason, if the quantity of the moisture which is present in the soil is less than field capacity of the soil, then the evapotranspiration will not be the maximum possible by the plant. It will be less in some proportion, and that is known as actual evapotranspiration. So this evapotranspiration term, the actual one, sometimes we can also call it as consumptive use. But either way, there is very little difference between evapotranspiration, consumptive use, and actual evapotranspiration. But PET is something which we need to look at. Only at field capacity, PET can happen. Then what are the various factors affecting? Also, we have discussed. So how evapotranspiration needs of a plant would be affected. Without much thought, you can easily say that the temperature, wind, etc. are the one which will greatly influence the requirement of water by the plant. So other than that, there are a variety of other things. This evapotranspiration need is a function of the crop and its variety and the season in which it is grown and the ambient conditions. There are a lot many things which can come into play, and all of this would influence the actual evapotranspiration. And the most important reason is that whether the water is present in the soil at field capacity, that alone would determine how much of that can be consumed by the plant for its needs. So this is something what is explained in a couple of paragraphs here, which we had discussed even in the last class. Now, how are we going to measure the measurement of factors affecting it? See here, measurement of factors affecting measurement of, it is not correct here. It is just measurements are done using lysimeter and field plots. When it comes to measurement of factors affecting, you would just say that I will send a small note on this crop and its variety, availability, type of soil, and availability of moisture in the soil. So let me type that here. If this is not part of the class notes, I will send it to you. You can just have a copy of that one. The measurement of factors affecting evapotranspiration. Just a minute. Rather, we will write factors affecting. We will just write this as fact because the other one will come later. Factors affecting measurement of evapotranspiration, crop and its variety, type of soil, and availability of moisture in the soil, the temperature, wind, and many more. So what do we mean by this? See here, a crop, certain types of crop would need more quantity of water and its varieties too. For example, rice is a water intensive crop. Sugarcane is a water intensive crop, whereas pulses would need less amount of water. So hence the evapotranspiration also depends on crop and its variety. Type of soil. See, you can have clay soil, you can have loam, you can have silt, you can have gravelly soil. The sucking of water through the plant roots is much easier in a very porous soil like a gravelly soil, because of which evapotranspiration can be at a higher level. Whereas the fine-grained clay type soil, we can have less amount of evapotranspiration. Similarly, if the temperature is very high, evapotranspiration needs are also high. If wind speed is more, evapotranspiration needs are also more. So these are the few important factors which will influence evapotranspiration. So how measurements are done? See, the measurements of these evapotranspiration are done by two methods. One is using lysimeter, the other is by using field plots. A lysimeter is nothing but a watertight tank. See, you can see it here. It is a watertight tank in which soil and crop both stay together. And it is normally kept adjacent to the plot in which a particular type of crop is being investigated for its evapotranspiration needs. Sometimes these lysimeters are buried in the soil just to simulate the condition that in the plot, the plant roots are also buried in the soil, and from the moisture available, it would grow. So because of which it is buried inside the soil. So then again, the same method what we adopt in pan evaporation method, whatever we did for determination of evaporation, here also the moisture content can be measured either volumetrically or gravimetrically. That is, an initial reading is taken before the start or commencement of the laboratory experiment, and a final reading is taken at the end. So that interval of time is also noted. So based on which it is possible for us to determine the evapotranspiration needs of the plant. So that is one of the best ways to do it under controlled conditions using a lysimeter. But we do have a problem. The exact simulation of the conditions as in the field is almost impossible in case of a lysimeter. So because of which, whatever results we get out of the lysimeter has to be corrected before using it for other purposes. Hence, accuracy would suffer in this particular case. Therefore, what is the next alternative? If lysimeter doesn't provide the required accuracy, what is the next choice? And not only that, lysimeter method is a time-consuming and expensive procedure. Say for many days, many seasons, with an attender, with all these lysimeters for different regions, spatially distributed. So all these things would involve a lot of labor, time, and expenditure too. And for any little change in the crop type, crop variety, nature of the crop, again, the same step of procedures have to be repeated. So because of which, and at the end, finally, we will not be able to get the desired accuracy by which we need to know the evapotranspiration. Hence, there are alternate methods. The alternate method is by using water budget equation. So what is this water budget equation? Already we have discussed the case of hydrologic cycle. And in that hydrologic cycle, we have also discussed abstractions or losses of precipitation. So here also, this evapotranspiration can be related in the form of an equation, which is nothing but precipitation, that is rainfall, plus irrigation, additional amount of water supplied to the crop, minus runoff, the one which goes away, and minus soil or groundwater moisture or water increase. So this is in a nutshell would represent an equation because of which it is possible for us to determine the evapotranspiration. But the exact determination of contribution towards groundwater is very difficult. How much of that will really get into groundwater is very difficult. But by keeping soil moisture around field capacity, this is very important, I said earlier, to meet the complete requirement of the consumptive use of the plant. If you can keep it at field capacity, the above equation will provide more or less a very accurate estimate as compared to lysimeter measurements. But in this context, even though it is not in syllabus, I wish to show you something which is state of the art in knowing all quantities or all abstractions of precipitation through a software application. So here, just look at this particular slide. So this is one slide which I want you to look at in greater detail. So you look at this slide, just a second. I will take it for slideshow if possible. Yeah. Is it visible? This slide is visible. Slide of a tree. Somebody please tell me.
Yes, sir.
Okay. Okay.
Yes, sir.
Okay. Now, it is not part of the syllabus, but part of the industry. Everybody should know about this. I will explain what it is. And this is something which we have done for Indian Space Research Organization project. We are working on ISRO Respond project, for which we are doing continuously work for the past 2 years. It is happening. This project will take another 1 year, for which we have grant of around 40 lakhs. So a team of 5 to 6 members are continuously working on this. And this picture is after running a software application called SWAT, SWAT, which stands for Soil Water Analysis Tool. And here it is written as ArcSWAT. This SWAT application is a module within ArcGIS. ArcGIS is an application which is helpful for us to generate various themes. I will come to that little later because it is not part of the syllabus. Let us not consume too much time. So what I wish to say is that SWAT is a software application which stands for Soil and Water Analysis Tool. And it is a module in another bigger application called ArcGIS, where ArcGIS helps us to prepare various geographic information system themes or shapefiles which are derived from remote sensing images. So that is something what you can remember. When we run ArcSWAT, this is the final output in the form of a picture we would get. And so as we will get in the form of table 2, this is what we would obtain. So whatever we are talking in respect of hydrologic cycle, that is precipitation and the various components like evapotranspiration, interception, groundwater flow, evapotranspiration, and all these things. And finally, the runoff, whatever we talk of. So here, the same thing, it calculates for a particular place depending on the rainfall and depending on the soil conditions which exist there, depending on the vegetation conditions which exist there, depending on the slope and other things which exist there, depending on the geology which exists there. That means to say that all influencing parameters in respect of determination of abstractions of precipitation are taken care of in SWAT. It would demand huge amount of data in calculating this. Having provided all details of geology, water bodies, precipitation, slope, and the other related conditions like vegetation, land use, land cover, all these things are provided. And also the value of the rainfall for the past few years are also being provided for this software application. And based on that, the precipitation here, it takes for one particular run. Annual precipitation value is shown here, 1065.7. And then based on this, based on other sets of data, it has calculated what is the quantity of evapotranspiration, 460.8. But actual evapotranspiration is 460.8. Potential evapotranspiration is 1280.2, because the soil at all times will not be completely saturated, because of which water will not be available at field capacity. Hence, actual evapotranspiration is less than potential evapotranspiration, which you can see here. PET stands at 1280.2, whereas actual evapotranspiration 460.8. Then the other abstractions, you look here, the shallow aquifer recharge, 24.4 units, mm. The percolation to shallow aquifer, 353.38. See, this is re-evaporation, this is percolation. Then lateral flow, just below the surface of the soil, 30.48. And surface runoff, the one which flows on ground at the time of rainfall, 231.83. Then return flow, which belatedly joins streams through subsurface flow, slightly at a lower level from the surface. Then recharge to deep aquifer, 17.67, that is groundwater. So all these things can easily be known by running this application software, which is called SWAT, or Soil Water Analysis Tool. If somebody wishes to do a project, probably this can be one good area in which you can think of your final year project. Please keep this in mind, just in case if you are interested. This is one of the very good things to happen. So this apart, we will continue. So that is how we are going to measure the value of evapotranspiration. The first method is method of lysimeter. The second is by field plots, so using the water budget equation. And then there is also another method by which we can measure this evapotranspiration, which takes the name Blanney criddle, the name of the persons or the irrigation engineers who arrived at this equation, because of which it is known as Blanney criddle equation. So this equation will also provide us an estimate of evapotranspiration, and how evapotranspiration is calculated in this particular method. So you just look at this one. The potential evapotranspiration, that is maximum evapotranspiration, it is ET, evapotranspiration, is calculated through this equation 2.54 K into F, where K is an empirical constant and F, sum of monthly consumptive use factors as defined below. So first of all, what is this K is an empirical constant? This empirical constant is a function of the type of the crop. Each crop will not have same quantity of evapotranspiration. That would vary. And depending on the type of the crop and the region in which it is being grown, because we know that already we have discussed the factors which influence evapotranspiration are these: crop and its variety, type of the soil, availability of moisture and soil, temperature, wind, many more means climate, the geographical locations, etc. All these things would become an important issue here. And because of which the crop coefficient K for each of the crops, what we are going to consider would vary. Suppose if you are thinking of our country, for example, if you are thinking of rice, let us say, see, not all varieties, but on a general basis, you can take an average value of 1.1. For K, rice is 1.1, wheat can be 0.65, maize can be 0.65, sugar cane 0.9, cotton 0.65. Similarly, if you are talking in terms of natural vegetation other than crop, they also would need soil moisture for their growth. And very dense natural vegetation, you can consider 1.3, something similar to rice. Dense vegetation 1.2, medium vegetation 1.0, light vegetation 0.8. So this is how we need to look at the average values of coefficient, which we can sometimes call as crop coefficient. In the previous article on evaporation, we thought of what is called as pan coefficient, and here we are thinking of crop coefficient. Pan coefficient for measurement or determination of evaporation. Crop coefficient is for determination of evapotranspiration. So this is something what you need to remember. So the general equation ET is 2.54 Kf. K is the crop coefficient. F is the monthly consumptive use factors as defined below. So how are you going to calculate these consumptive use factors? Some of them. See here, pH is percent annual daytime hours. I said evapotranspiration is a function of temperature. So the daytime hours are very much necessary, pH. And TF is the mean monthly temperature expressed in Fahrenheit. You remember, not in degree centigrade. It is in degree Fahrenheit, not in degree centigrade, but in degree Fahrenheit. So of that particular place. So the mean monthly temperature, what you are going to take can be obtained from the latitude of the place or location of the place. So you have to be very careful about that, right? So these two equations, the first equation, ET 2.54 Kf, and the expression to define F is given by Blanney criddle. And we have to make use of these two equations in order to determine the evapotranspiration of a particular crop. So which we can understand through the following example. We will look at this numerical example. So I will just go through this numerical example, before which, as usual, a quick snap for the attendance here. I would take that and continue. Just hold on for a while. I will take a few snaps of this. Just a second. So please be online. I should not miss anything. One second. Still not done. Not done yet. It takes some time because I have to capture everything. Last one. Okay, I'm done with this. Now we will look at this example. See here, the example is here. Estimate the potential evapotranspiration of an area for the season November to February in which wheat is grown. The area is in North India at a latitude of 30° north with mean monthly temperatures as below. Crop coefficient is 0.65 and pH values are from table depending on the latitude. Now here you have to understand one thing. The moment we are provided with the latitude, the monthly temperature and daytime sunshine hours can be obtained from a table. And in the problem statement, the temperature is given, whereas in this problem statement, the value of pH is taken from the table. In the examination, you will be provided with these 3 columns of data. So you will have temperature, 1 second. So this is also temperature. You have this month, you have temperature, as well you will have daytime sunshine hours. You would have these 3 values, month, temperature, and then pH. So these 3 values will be given to you. So using this, you have to calculate the consumptive use for the given situation. How are you going to do that? Let me copy these details to Excel. In exam anyway, you will use calculator for the purpose. So let me just put it here. So I have month, temperature, and another data which is provided for us is sunshine hours, daytime sunshine hours. So here, so I will put that also here. See here, this is daytime sunshine hours, pH, already defined here. You can look at that pH. See here, monthly, percent annual, daytime sunshine hours. This is done. So using this and these 2 equations, I have this equation. I will copy that again here. One equation to determine evapotranspiration total. Then to calculate consumptive use factor, F. Individual consumptive use factor should be first calculated, then they should be added, for which you have to use this equation. So I will take that equation also here, somewhere here. Okay, these 2 equations have to be used. Now, please remember one thing I said earlier, in using this equation for consumptive use factor determination, this uppercase F, whatever you are required to determine, the temperature substitution, this TF, the temperature, it is written as TF because it should be in Fahrenheit. The given data represents temperature in degrees. So please remember one thing, the relationship between degree centigrade and Fahrenheit, C by 5 is equal to F minus 32 divided by 9 is the relationship between centigrade and Fahrenheit. You should be aware of this, where C stands for degree Celsius, F stands for Fahrenheit, degree Fahrenheit. So here values of temperature are given in degrees. You have to convert that into Fahrenheit. So how are you going to do that? So here, if you rearrange this equation, you have to write C divided by 5 star 9 plus 32 will become your degree Fahrenheit F. So the same thing I would calculate here, temperature F. So that we need to calculate the temperature value we need to calculate. So if you calculate that, I would do that here using Excel. C by 5, that is temperature in degrees Celsius divided by 5 star 9 plus 32. done. So similarly, I will do it for other cases also, for other months. It is done. Temperature in Fahrenheit. This is temperature in degrees. A higher number always in Fahrenheit you would obtain. Then you, for each month, calculate pH into TF divided by 100. And then add all of that to get sigma. That means the first one, this one, pH, that is pH is nothing but daytime sunshine hour, 7.19. Then Fahrenheit temperature here divided by 100. So you calculate this, you get 4.43623. Similarly, for the other cases also, you would do it with corresponding values of pH and degree Fahrenheit. See here, pH, degree Fahrenheit, you get this. pH, degree Fahrenheit, pH, degree Fahrenheit, you get this. So sum all of these four, you get the sum of this, sum of all this. So this value, whatever F you have, is represented here. This F value is nothing but, see, this F value is 16.2632. This is the value for F. Then you have to calculate ET. ET is 2.54 kF. So K value is given as the problem statement, given in the problem statement. See here, if you look into the problem, crop coefficient is 0.65. You can look at this, 0.65. It is already mentioned. So you just go there. So the value of ET, evapotranspiration, will be equal to 2.54 into K. K value is 0.65. So star 0.65 into F, you have calculated, that is 16.2632. So many mm is the value. The unit is not mentioned here. Normally it is taken in mm. SI units, 26.85 mm is the evapotranspiration you would calculate for this situation for all 4 seasons together. So you look for the units here. Since not much is mentioned here, you can consider them in millimeters. So suppose if you go back to the class notes here, see 26.85048. Same thing. Slight difference, but not much of worry. Is this clear to everyone? We may be running out of time in a minute. You please rejoin immediately after. Is this point clear to everyone?
Yes, sir.
Okay. Okay. Then we will move further.